Okay, how about the projects? The projects are due today. I mentioned in the email that what I needed as far as the printed copy, and also asked that you upload your Excel file to MU Online. Does anybody need me to demonstrate how to do that, how to upload the files to MU Online? I can go over that quickly. It's just as easy as logging into MU Online and finding our course. And then there's just a spot where you can browse to your file and upload it. If you didn't already upload your Excel file, please do that immediately after class. I may have some need to, if the spreadsheet is so small I can't see the figures, or if I want to double check your calculations, I will need access to the spreadsheet file. So please make sure that those are uploaded. Project's done. Don't you feel good? Isn't that like a weight off your back? Now you don't have to worry about it. Just finished. I will grade those by next week. What I'd like to give you next week is an updated printout showing what your grade is in the course up till now, including the effect of the project. And based on the questions I was getting, it seems like the project could be very good. So I'm looking forward to go through those. All right. Well, today I'm going to give you a new homework assignment that's due next week, and this new homework assignment is covering some of the concepts from Chapter 6. Our first lecture in Chapter 6 was last time, the recorded lecture, Comparing and Selection Among Alternatives. And what we're going to do today is talk about incremental internal rate of return analysis. And we'll get into that just in a minute. But any questions on these announcements, or just in general, things that have been on your mind related to the course? Class 13 of 15, by the way. After today, we've only got 2 more lectures. So we're really nearing the end. The computer's a little bit locked up. Okay, here we go. Now, remember that one of the ways that we can compare alternatives is to find out which looks best when we do the EW methods, and that means equivalent worth. Equivalent meaning that we take all of the alternatives to some common frame of reference. We either take everything to the present, we take everything to some future date, or we find the annual value of each of the alternatives. And so when you're comparing alternatives, you can always rely on the equivalent worth method to point out which of those alternatives is best. But the problem is remember, you simply are using the MAR. Did I give you notes already? I didn't, did I? All right. Here's the notes for today's lecture. Okay, the problem with the equivalent worth method is it doesn't necessarily tell you directly what the rate of return of the alternatives is. It simply tells you that if you have a certain minimum acceptable rate of return, whether or not a project should be conducted. And so we might want to calculate the internal rate of return on a project just to get a sense for how profitable it is. Can anybody remind me what is the big assumption that we make when we are calculating the IRR?
Be profitable.
Okay. First of all, you can only calculate the IRR for a project that is profitable. That's an important point. We wouldn't be able to calculate IRR for a cost alternative, for example, because remember, cost alternatives are those which only have expenses. And then Christian, I heard you say the other. Oh, okay. Evan, what was the other one? Okay, it's assuming that all of the cash flows that are generated are reinvested in the project at the same rate as they are generated. In other words, it assumes compound interest. The IRR assumes that you're leaving it in that project and that any interest you make on the project is generating interest at the same rate that it was generated in the first place. So here I have an example of a spreadsheet where we've got a certain number of years and alternative A and alternative B that we're comparing. We've got a MAR of 10%, so that's the minimum that we'd accept. And you can see alternative A costs us $60,000 up front, alternative B costs $73,000. Now, we're willing to spend more for alternative B because it's generating additional cash flow through those 4 years. It's costing us an extra $13,000, but you'll see that that means we get an extra $4,225 every year for the next 4 years. So the question is it worthwhile to do that? Should we do A or should we do B? Well, if we use the present worth method, then what we find out is that alternative B has the highest present worth. And what I'll tell you is you can always rely on a present worth method to identify the best alternative. So option B is better than option A because it generates a higher present worth. But now look at when we calculate the IRRs. It's not that there's a mistake in these IRRs. These IRRs have been calculated correctly, but the point is that you can't rely on the IRR to identify the best project. Even though this has a higher internal rate of return, it's not the better of the two projects. And so there's a discrepancy there that we need to talk about, and that discrepancy is going to lead to a new method of analysis that we're going to be able to apply. Okay, so the incremental analysis is what comes out of that discrepancy. And an incremental analysis means that instead of calculating the IRR of the cash flow, what we should do is we should calculate the internal rate of return on the extra amount that project B cost. And so I already told you it costs an extra $13,000. So the question is, should we spend that extra $13,000 or not? Is it worth making the greater investment? And what this analysis is going to show is that yes, it is worth making that extra investment because the rate of return of the increment is above the MAR. Remember, we should keep spending and spending and spending as long as each additional dollar we invest makes more than the MAR in terms of the return. As long as you can make more than your minimum, then you should go for the biggest project you can. Finance the largest possible project as long as the incremental cost can be justified. And so what this is showing is if you have B minus A, so how much extra did project B cost compared to project A? Well, it's an extra $13,000. And now what you do is you do the same thing, B minus A, for these benefits. And so there's the extra $4,225. And so that if we can calculate the present worth of this cash flow, and it's positive. So if it's positive, that means that this extra $13,000 is justified. And now if we calculate the internal rate of return, it means that this extra $13,000 is going to give you an 11% return. And since 11% is more than 10%, then yes, you should go ahead and generate the extra cash flow by going for the more expensive option. Does everybody feel comfortable with what this new column is? Because basically right there in about 4 minutes I've shown you what today's whole lecture is all about. It's a very straightforward approach. It's just when you compare alternatives, you line them up in order of cheapest on the left, more expensive going rightwards, and then you calculate the difference between each additional cost to find out how much is that extra revenue costing in terms of the extra investment up front. So the concept here, the rule that you need to keep in mind is that if the internal rate of return of the difference between two alternatives is greater than the MAR, then the additional investment is justified. Okay, so now why was it that we had that discrepancy? At first, it was looking like the internal rate of return method and the present worth method were identifying different projects. And it looked like we were getting a different answer depending on what option we were choosing. Now, the reason for that apparent discrepancy is that we were comparing apples and oranges. Remember that when you calculate the internal rate of return, it's assuming that, that the additional dollars are being generated at the same rate that they were initially generated, and that's not necessarily true. And so when we calculate the internal rate of return between two projects, there's different interest rates. But when we calculate the present worth of the projects, we're using the same interest rate. And so the way that we're comparing alternatives is consistent when we were using the first of those two methods. When we did the present worth of both, we were using the same MAR. When you do the internal rate of return, you're discounting the cash flow at whatever the IRR is. And since there were different IRRs, we got a different analysis that would lead us astray if we're using it for decision making. And so, like I said, the thing that we need to do is calculate the increment. And this is a figure in your book that I think is important for you to take a look at. And what it shows is the effect of the interest rate that you're using for discounting on the present worth. And so this is like a graphical illustration of the example that we just looked at. So it's showing that if your interest rate is 10%, option A had a present worth of $10,131. Option B had, that was option B. Option A was $9,738. So if you continue to discount them at increasing interest rates, the interest rate that makes the cash flow diagram equal to 0 is where it crosses the line. And so we found that the internal rate of return of option A was 17.3, of option B was 16.3, but the internal rate of return of the difference, the internal rate of return delta, was 11.4, and that is the additional investment internal rate of return. So there were two curves that intersect, and when we solve for the incremental rate of return, then that, graphically speaking, is that point of intersection here. So this will tell us how much the extra investment is going to be generating. So again, if I asked you to use the internal rate of return to compare alternatives, that would be a trick question. Because the trick is that you'd be tempted to calculate the IRR of both and then pick the one with the highest IRR. But what you really need to do is find the difference between the two cash flow diagrams and then calculate the IRR on the difference. All right. So here's what it would look like if you had more than two alternatives. Let's say that you've got several different options here to try and compare. You've got option A, B, C, D, E, F. You can see that all of them are arranged in order of increasing initial expense. So I've got the cheapest one in the leftmost column and the most expensive, the $7,000 initial cost, in the leftmost of them. Now, if I just do the present worth analysis, it shows me that, first of all, option C is just a bad deal. You can see the present worth of that is negative. So, of course, we don't want to do option C at all. But now the question is should we do option A, B, D, E, or F? Which one of them is the best? The present worth says that option E is going to give us the highest present worth, but can we use the incremental internal rate of return method to prove that? So let's go through the steps of how that would be proved. The first thing you do is you compare option B to option A. So if I just go back to the previous slide, that's showing B minus A, so I'm going to have an extra $600 as the initial upfront cost, and then it's going to be generating an additional $126 in revenue each of the years. So B minus A. And I do that, and I find the internal rate of return on the increment is 16.4 compared to the MAR of 10%. So as long as this delta IRR is above 10%, then we'd say yes, do option B instead of option A. That's what the yes means, is spend the extra amount. Now, we already eliminated option C because it has a negative present worth. And so I don't even bother comparing option C to option B. I just jump ahead. This next column is like my next analysis. So my next decision is, should I do B or should I do D? D is going to cost more than B. So I subtract the extra cost. I have 4,000 minus 1,500. So the extra cost is going to be 2,500. And then I also want to find the extra revenue that's going to be generated, D versus B. So that's what this column is here's the extra cost comparing D and B. And here is the additional revenue that I get. And so I calculate the IRR. And remember, that's just as easy in Excel as doing equals IRR and then selecting the entire cash flow diagram. And it automatically calculates the IRR for you. And as long as it's above 10%, then yes, you should do the more expensive option. So go ahead and do D, because that incremental cost, you spend an extra $2,500, but you get back a lot more than that. So it's definitely worth borrowing money from the bank at 10% so that you can make 22.6% on that additional $2,500 investment. That's a good investment. And so we say, yes, do D instead of B. And now we want to look at the comparison between E and D. And so now this $1,000 is simply how much more option E costs compares to option D. So the same thing, here's the differential cost, here's the differential benefits, and again, the internal rate of return is above 10%, so we should do option E. So we've sort of thrown out option A. Even though it's profitable, we don't want to do that one because there's a better choice. Option B was better. But then we showed option D is better than B, E is better than D, but now in the comparison of option F and E, it looks like that's an extra $2,000 we have to spend to go for option F. And the question is, should we bother with that extra $2,000? And what this analysis shows is that we're spending an extra $2,000, but it's only getting us $300 more in revenue. And the internal rate of return of this entire cash flow is 8.1%. And so it wouldn't make sense to borrow money from the bank at 10% if you're only going to make 8.1% on that additional amount. And so the overall conclusion here in this series of analyses is that option E is the best. E was the most profitable because each of the incremental costs could be justified. So again, a summary of our steps that we did is we sort the alternatives by increasing initial investment. Left is the cheapest, right is the most expensive. Subtract the difference between the columns, and then we find the internal rate of return of the difference. All right, so what I'm going to do is I've got an in-class exercise for you. And in fact, let me also give you the homework assignment. Here's the homework for Chapter 6. This is the one that's due in class next time. It's relatively short. Okay, it is 4:37, and I think that this in-class exercise is pretty straightforward. You know, some of you may finish it as quickly as 5 o'clock. I'm going to set out the solution, and I'm also going to have it up on the screen. But the incremental internal rate of return is the only additional topic from Chapter 6 that we hadn't already covered in that online lecture. Like I mentioned at the beginning of class, we might get out a little bit early tonight. All right, so go ahead and fire up the computers. You can use your laptop if you prefer.